Have you ever stopped to think about how your phone knows your face? Or how a website can translate an entire article in the blink of an eye? It honestly feels like magic. But what if I told you the basic idea behind it is actually, well, pretty simple? Today, we're going to pull back the curtain on how machines actually learn. And we're going to do it by looking at the really cool concepts behind artificial neural networks.
All right, let's get right into it. To really get our heads around machine learning, we first have to understand why it's such a huge shift from, the way computer programs normally work. So check this out. This slide basically flips the whole process on its head. In a normal program, a programmer, a person, has to write out every single rule. You give the computer some data, it follows the rules you wrote, and poof, you get an answer. But with machine learning, it's the other way around. You give the machine the data and the answers, and you tell it, okay, you figure out the rules that get me from here to there. And that right there is the million-dollar question, isn't it? If we're not telling the machine what to do step by step, how in the world does it figure out the process all by itself? Well, the answer is surprisingly human. It all boils down to a process that's a lot like a simple guessing game. Honestly, this is the core aha moment for understanding how this stuff works.
Okay, so let's look at this super simple example. We give a computer this data. Now, you and I can look at this and see the pattern instantly, right? The output y is just 2 times the input x. The rule is y equals 2x. Simple. But remember, the computer has no idea. Its entire job is to figure that out from scratch.
So how does it do it? It follows this simple little loop. First, it just takes a wild guess. Maybe it says, I think the rule is y equals 1x. Then it looks at the real answers and sees how wrong its guess was. And here's the key. It uses how wrong it was to make a slightly better guess the next time. And it just does this again and again and again, getting a tiny bit less wrong with every single loop. And this brings us to a really important idea. The cost function. It sounds technical, but it's not. It's just a score for how wrong the machine is. You can think of it like losing points in a game. The goal of the entire game, the only thing the machine is trying to do is get that error score, that cost, as close to 0 as it possibly can. This graph shows it perfectly. Imagine every possible guess creates this giant curve. Being way up high means your guess is terrible. The cost is high. The goal is to get to the very bottom of that valley, where the error is the lowest. So the machine takes a small step in whatever direction is downhill. It's always trying to find the bottom, the point of lowest error. This whole process is called gradient descent. Okay, so that's the engine, guess and adjust. Now let's look at the vehicle it powers. And for that, we're going to look at the most amazing computer we know of, the human brain. I mean, just think about it. The human brain has something like 100 billion neurons. That's a level of complexity that is just, it's mind-boggling. We can't even come close to building something like that right now. But here's the thing. It turns out we don't have to. Because look at this, a tiny little nematode worm. It can find food, run from danger, live its whole life with a nervous system of just 302 neurons. And that is a huge insight. It tells us that you can get really smart, effective behavior from a network that's actually simple enough for us to build and simulate with the computers we have today. It gives us a starting point, a blueprint. So we create an artificial neuron. It's just a simple model of a real one. It basically works like this. It gets a bunch of signals coming in, it adds them all up. And if the total signal is strong enough, if it crosses a certain line, it fires off a signal of its own. It's like a tiny little decision maker. Okay, so this is where the magic really starts to happen. We've got these artificial neurons inspired by the brain, and we've got our guess and adjust learning method. How do we put them together? We arrange the neurons in layers. You have an input layer where the data comes in. Then it goes to one or more hidden layers. This is where all the complicated processing happens. People sometimes call this a black box because it can be tough to see exactly what's going on in there. And finally, you get a result from the output layer. Now, the real secret sauce is in the connections between the neurons. Every single connection has something called a weight. You can just think of it as a number that controls the strength of that connection. It's like a volume knob. A high weight turns up the signal, making it more important. A low weight turns it down. And this is the moment it all clicks together. Remember our simple guessing game? The neural network is doing the exact same thing, but instead of adjusting one little number,
It's adjusting the thousands or millions of these little volume knobs, these weights, all at once. The network's guess is just the current setting of all of its weights.
So when the network makes a guess and it's wrong, the error gets sent backward through the whole system. It's like a game of telephone, but in reverse. The output layer says, nope, that was wrong, and a message about how wrong it was travels all the way back. Every single connection hears that message and adjusts its own little weight, its own volume knob, just a tiny bit to try and do better next time. This whole process is called backpropagation, and it's how the entire network learns from one single mistake.
Okay, let's just take a step back for a second and really nail down the main idea here, because it's so cool.
So here it is, the big takeaway. All of this amazing, complex, seemingly intelligent behavior, it all comes from one ridiculously simple rule. Keep adjusting the strength of the connections between neurons to make your guess a little bit less wrong than it was last time. That's the whole game. Simple rules creating incredibly complex behavior.
And that just leaves us with this one final, pretty mind-blowing thought. Everything we see in modern AI, from self-driving cars to medical discoveries, is built on this foundation of just guessing, checking how wrong you are, and making a slightly better guess. If that simple little loop can already do all of this, what incredible problems are we going to see it solve next?